Okay guys, this video is about the required practical IV characteristics linked to that lesson. Basically it is 3 practicals in one using this main circuit. Okay, so remember that IV, I means current, V means potential difference. I is electric current, is the flow of electrical charge. The size of the electric current is the rate of flow of electrical charge, and electrical current is measured in amps using an ammeter. Now, which is ammeter. Now, potential difference, or V, is the measurement of how much energy is transferred between 2 points in a circuit. Potential difference is measured in volts using a voltmeter. So, there are 3 main parts to this practical. It's fundamentally the same practical 3 times using the equipment here. Now, we've got an X here, and that red X is the only part that changes within the 3 different practicals. So, we have got the lamp, we have got a LED, which is very small, which is an LED, and we have got, even smaller, a resistor. And what we do is that we are going to measure the current change within that circuit as we alter the potential difference. Now, these are the components that we're going to use in the circuit. We have got the voltmeter and the ammeter, we've got the lamp, and we've got the LED, the diode, light emitting diode. You can use just a diode, but I think light emitting diodes are slightly better in this practical. And you've got the resistor of any variety you like. Now, we've also got this device, which is the variable resistor. Huge thing, it doesn't need to be this big, but it's just nice and easy. What we do is you plug the wires in at both ends within the circuit, and you move this up and down in order to change the resistance and to change the potential difference within the circuit. So when you change the push, potential difference, you change the flow, which is the current, and then we measure the current. And obviously, the provider of the potential difference, provider of the push, is the power pack. Now, I'm not going to do all 3 together because they are virtually identical. It's what's important is, one, the method, which, as I say, is identical for all 3, or pretty much identical for all 3. And also the results. Looking at the results and interpreting the results is the real key part of this practical. If we look at this, this is going to be the one that I'm going to do, which is using the lamp. But in essence, once you've done the lamp, then you can do all 3. You just replace the lamp with the LED, and then with the resistor. Now, when you are doing the practical, you need to record the results. And what you do is you record the potential difference and the current in this table here. Potential difference V, which you alter using the variable resistor. As you move that up, then the potential difference changes, the push changes within the circuit. And as a consequence, you will get a change in the flow, which is the ammeter, the current. Change the push, get a change of flow. And this is the V and this is the I. V is the push, I is the flow. Okay? Now, when you've done that, you need to be able to plot those values on a graph. So V is the x-axis and Y, the y-axis is the current. Now you'll notice that also has some negative values in there as well. Halfway through the practical, once we've got the first set of results, we're going to change the terminals round on the power pack, so it changes the direction of the current. When we've done that, we will start to get some negative results which can be plotted on the graph. Then we can analyse the 3 different shapes of graph depending on what is produced by the 3 different components. Okay, here we have got a power pack, and we have got a variable resistor. The whole point of a variable resistor is to obviously change the resistance, change the potential difference that's going through the circuit as it goes up. As you move it one way, it changes the resistance and changes the potential difference either up or down. So we can control the potential difference, which we obviously measure on the voltmeter. It obviously changes the current whilst it's doing it. So the potential difference is the push and the current is the flow. So without push you don't get flow, the more push, the more flow. Okay, so you've got the variable resistor, you've obviously got the voltmeter, which you're very familiar with, that goes over the top of a component. The component is the lamp. Okay, and then we have got an ammeter or a milliammeter. We also have got resistors, and we have got the, so we've got a resistor, which is there. Oops, pick that up. We've got the resistor, and then we've also got the LED. So that's the LED, and that's the resistor. So what we do is we connect everything up in circuit, in series. We measure the current, and we measure potential difference. We then change the resistance, and then we measure those, and then we measure the current and the resistance, current and the potential difference again. Okay, so the three different types of circuit. So it's three different practicals with three different circuits. This one is the diode. This one is the resistor, and this one is the lamp. Okay, so three different circuits. The circuit that we're going to do first. So let's put those two to one side because those are the second two. The resistor at a constant temperature and the LED. These are two other the practical 2 and practical 3. So we'll put those to one side. And then so the first practical we're going to do is this setup here, where you've got a series circuit with a lamp in it and a variable resistor. And when you've done that, you put the voltmeter over the top, and then you can adjust the potential difference, the resistance, using the variable resistor, and take the readings. And then from that you can plot the graph. Okay, so let's set this up very, very quickly. You have got your lamp. Let's just check if the lamp is working by turning it on. Make sure it doesn't blow up. There you go, lovely, lamp is working. Now the next thing is we need to connect that into there, and that into there. So that's the basic circuit. There you can see you have got the ammeter, you have got the variable resistor, and you have got the lamp in a nice circuit. Okay. Okay, now what you do is you get your voltmeter and measure the potential difference over the top of the you get your current, you get your potential difference, and then what you do is you move this about. As you can see, as you move this about, you get different readings on the potential difference, different readings on the ammeter, and this is created by changing the resistance in this. We're using this variable resistor, using this methodology, and then you write this down in a table, which will come up shortly. When you're halfway through, you change the values. So you swap these about, swap the terminals about, and you'll notice you then start getting negative values on the ammeter and the voltmeter. This because when you change the values, you change the potential difference push, and you change the difference, change the direction of the current from one way to the next just by changing the values on that, and that's where you get your graph going from one side to the next. Okay, so let's start the practical. Okay, so this is how we got everything set up lovely now. Let's make sure everything's turned on. Let's write some values in. Ooh, nice and bright. So let's write some values in. This is right at the beginning, so we've got 5.335. Okay, and if we move this up and down, you can see as it goes down, potential difference goes down, and the ammeter goes down, and you can see the bulb goes down, so the current goes down, the potential difference goes down. So let's start it as low as we can get it. So let's start it at 0. If we start it at 0, let's start it at 0.3, 0 will be 0, 0.26, 0.26, these are positive values, and 0.49. Move this up slightly, 0.425, 0.5. Let's move it up slightly more. Move it to 0. Let's move it to 0.5. And the temperamental 0.5, 0.66. 0.5, 0.66. Now let's move it up to 1. So what we do is we're going to move this up to 1 volt. And then, so we're changing the potential differences in this. You've got 1 volt, as you can see the potential difference is going up. That's close enough. 1 and plus 1. And then we've got 0.84. Let's go up to 2. Let's go to 1.5, shall we? 1.5. 1.5. There we go. That's 1.5. And that's 0.99. Let's go up to 2. See what we can get up to. And then, oh, come on. 2. Nope. 2. Oh. They're not the most precise things. There we go. That's close enough. 2. And 1.12. And 2 and 1.12. Let's go a bit more. Come on. There we go. 2.5. 1. And 1.24. Zero and 1.35. What we're now going to do is we are going to reverse the values. So you've got potential difference on one side, current on the other. Turn it off. Just reverse the values. So you get negative. We can work backwards. So we've got minus 3.6. Is minus 1.47. And you've got minus 3 is minus 1.35. We'll round these values up when we plot the graph. 3. And then you've got minus 2.02. 1.11. So there you have it, a full set of data. Okay, these are the results that we got. And from these results, you can see, and this is with the lamp, this is for the diode, and this is for the resistor in the circuit. And from these results, we can plot potential difference against current for each, the lamp, the diode, and the resistor. So these are the graphs. Now, the first graph we can see is the resistor at constant temperature. Now, when you plot these, it forms a beautiful straight line. Okay, like this. This is because it is an ohmic conductor, which means that as you raise the potential difference, then the current increases proportionately. Slightly different when you look at the lamp, because what you have there is this curve shape. Okay, and this is due to the fact that as the electrons in the wire get more energy, more kinetic energy, and thermal energy increases, then the resistance increases, and you get this curvature shape here. With the diode, you get a different shape altogether, because the diode prevents the flow of current in one direction. You get this shape. So as you reverse the current flow, it stopped going that way. Stopped going one way, whereas it allows it to go the other way, and that's why you get this shape.